Howdy, we are Group 54 and we're going to be presenting Bayes' rule. So part of Bayes' rule is conditional probability. Conditional probability is the possibility of an event or outcome happening based on the existence of a previous outcome. So how to calculate this would be first to need the variables probability of evidence, probability of the hypothesis, probability of the evidence conditional upon the hypothesis, and then probability of the hypothesis conditional upon the evidence. And just like it says in our notes, to find the probability of the hypothesis conditional upon the evidence, it's P H of E is equal to P H of E of H times probability of the hypothesis all over the inverse of the probability of the evidence upon the hypothesis times the probability of the hypothesis plus the probability of the evidence based on the opposite hypothesis times the inverse of the probability of the hypothesis. The purpose of Bayes' rule. The purpose of Bayes' rule is to establish the credibility of a hypothesis or test. An example of this is used in the notes is establishing the credibility of a medical test based on the probability of whether or not someone has the disease will test positive for it. Example, probability of testing positive and having the disease is 90%, and the probability of testing positive and not having the disease is 10%. Based off this, we can say that the test is credible and that you're probably going to get an accurate reading when you use it. Another example would be if you're testing with products, say that you want to use a new accounting software for your business, but you don't know which program is the most reliable. You can use Bayes' rule to find out which software program is the most reliable based on data that the manufacturers give you, or if you want to do your own testing yourself.
Now we have the functions in Bayes' rule, or the probabilities and variables. We have the probability of the hypothesis, probability of evidence conditional upon the hypothesis, probability of hypothesis conditional upon the evidence, which is what we're searching for, and the negation of H, which is probability of it not being the hypothesis. Here's Bayes' rule restated right here. And underneath this is the generalized form of Bayes' rule, which is used for multiple hypothesis testing for any number of mutually exclusive or exhaustive hypotheses. For our problem, we're asked if Cynthia gets assigned the blue program. Here we have the program crashes, or the probability of the program crashes, the assigned program based on 10 employees, and now we're going to use this information Bayes' rule. Since we're asked what color she was assigned, this is the hypothesis. The probability that she's blue is 10% chance. The probability the program crashes, 30% chance, is the evidence. And the negation of H is the probability it was orange or red, which 9 people are not blue. For the weight, 6 out of 9 people are red, multiplied by 10% chance of it crashing, plus 3 out of 9 people being orange, multiplied by 20% chance of this program crashing, equals the probability that someone not blue, their program crashing. This is equal to the negation of H, so we can now plug it into Bayes' rule. So we have 10% chance of Cynthia being blue, multiplied by 30% chance of the program crashing, divided by the same thing right here, plus 90% chance that the program is not blue, multiplied by the probability the program crashes based on it not being blue. We then have the same thing, but in this case, red, Cynthia being assigned the red program. The only thing that changes is the numbers. The hypothesis is still the probability that she is red, which is 60% chance. The probability the program crashes is 10% chance. And the negation changes here with 4 people that are not red. So 3 out of 4 people are orange, multiplied by 20% chance this program crashes, plus 1 out of 4 people being blue times 30% chance this program crashes, which gives us the probability of not being assigned red, the program crashes. So we take this and we put it into Bayes' rule, with Cynthia being 60% chance to be red multiplied by 10% chance for the program to crash. Same thing down here, but it's added to 40% chance of not being assigned red, and then multiplied by the probability that a program that is not red crashing.
In hooks, going over point 5 of problem number 1. So let's discuss the final calculations of the problem. The total of the entirety of the probability would equal to 0.15. Meanwhile, the probability of blue crashing would equal to 0.2. And the probability of red crashing would equal to 0.4. Probability that Cynthia was assigned blue given the program crashed would be 0.20, or 20%. And probability that Cynthia was assigned red given that the program crashed would be 0.40, or 40%.